Okay, so on I believe was it Monday? Quiet down, please. On Monday, we started with the percent yield review, and I gave you this definitions. Oh, well, I already gave the definition. This is your next problem. This one actually deals with how we do limiting reactants. Okay, so please take your notes out. It reads as solutions of aluminum chloride and silver nitrate react to form precipitate silver chloride in a solution of aluminum nitrate. And in this case, they gave you already a balanced reaction that is written out correctly with the charges balanced out. So this reaction is good to go. Now, the question is, if you start off with 20 grams of aluminum chloride and 20 grams of silver nitrate, which one is a limiting reactant? Okay, so this is when we have to make two separate predictions. First, I'm going to choose to write 20 grams of aluminum chloride and 20 grams of silver nitrate. These are my two starting reactants. I'm going to pick one and predict how much of one of the products I'm going to form. You can just do it for one of them. So, between aluminum nitrate and silver chloride, I'm thinking that I would like to do it for, let me actually first click this off. I would like to do it for silver chloride. It doesn't usually matter, but the reason I'm choosing silver chloride is because the problem's asking in the second part how much silver chloride is formed, right? In other words, when they're doing percent yield problem and they said, what is the percent yield of so-and-so, that's the product you want to look for. In this case, they asked you what the mass of silver chloride is, so I'm going to use these guys, one of each, to predict how much silver chloride I'm going to form. So if I were to draw my path, my first prediction is going to go from aluminum chloride to silver chloride. That's my first prediction. My second prediction is going to go from silver nitrate to the same exact product. You have to predict the same type of product. You can't just say, I'm going to use aluminum chloride and I'm going to go to silver chloride. Then I'm going to use silver to this. No. They both have to predict the same thing. So in this particular case, I'm going to do my first prediction first. That's why I'm starting out with aluminum chloride, right? It's in grams, so what's my next step? So I have to convert to moles, right? So I'm starting out with grams, and I'm going to go ahead and convert it to moles. And the amount of grams I'm going to get at the bottom, I have to get it from where? The periodic table. If that's the case, the unit at the top has to be what? How many moles? 1 mole. So when I find the mass of aluminum chloride, it ends up being 133.33. The grams of aluminum chloride cancels, and now I am at moles of aluminum chloride. I wanted to go from aluminum chloride to what? Silver chloride. So now that I have aluminum chloride, I need to use what to get to silver chloride? The coefficient. So my next step should look something like this. My moles of aluminum chloride cancel, and now I'm at moles of silver chloride. The question is asking what mass of silver chloride is produced. So that means when I have this mole of AgCl, I'm not done. What do I need to do? I need to convert it to the mass, right? By doing that, by doing 1 mole at the bottom, and the mass of AgCl that I get from the periodic table, which is molar mass, I get 143.35 grams for every 1 mole. Now, I want to highlight the fact that this and this both are your mass from the periodic table. So when I do the math, I should get 64.5 grams. That's my prediction. What that means is that if my aluminum chloride is my limiting reactant, I should get 64.5 grams of silver chloride. That's if. I don't know if it's the right prediction yet, because I have to do the next step as well. Okay, so next step, instead of starting with aluminum chloride, what am I starting with? I'm starting with silver nitrate. And I'm going to start from silver nitrate and go to what? Silver chloride. Aluminum chloride is your other reactant, so I'm not going to that yet. I'm going from silver nitrate to silver chloride, and that's my second prediction. And that's how I'm going to start my prediction with. I have, what this is saying, I have enough AlCl3 to make up to 64.5 grams of AgCl, and that's part of the first problem. I'm going to go ahead and make my second prediction using silver nitrate. I have 20 grams of silver nitrate. Let's put the phone away, Tyler. And I'm going to take that grams and convert them to what? I'm going to convert to moles. So again, this is a molar mass of 1 mole of AgNO3, and I get this from the periodic table as well. Grams of AgNO3 cancels out, and now I'm at moles of AgNO3. You told me that from moles of AgNO3, I need to go to AgCl. So to go over that to the product side, I need to use what? The coefficient. In this case, it's 3 to 3. So that's what I get. My moles of AgNO3 cancels out, and now I'm left with moles of AgCl. Again, the question is not asking how many moles you're going to form, instead how much mass you're going to form. So I'm going to convert it using exactly the same mass. So for every 1 mole of AgCl, I'm going to end up with 143.35 grams. Moles of AgCl cancels out. When you finally do the math, you get 16.9 grams of AgCl. What that means is that I have enough silver nitrate to make up to 16.9 grams of AgCl. So this is my prediction 1 at the top. This is my prediction 2. Which prediction is the accurate prediction? First or the second? Second. Why is the second one the correct prediction? Because it's the smaller prediction. So what that means is that AgNO3 is my limiting reactant because it's smaller, and the amount of AgCl that I get using AgNO3 is my theoretical yield. Limiting reactant produces a theoretical yield. So I'm going to write that up here. Limiting reactant produces theoretical yield. Now, if that's my theoretical yield, and this is my limiting reactant, what is AlCl3 then? That's the excess, because that's what's going to have leftovers. This is the excess reagent or reactant. Question? Yeah.
You know how if it was 1 to 3, you know how you do that before? How come you found
We did. Right here, 3 to 3.
Remember before, if you had 20 in the air, you had 20 in the air, you had 2. You see the 3 in front of AgNO3?
Yeah.
Is it 3 in front of AgCl?
Yeah.
When you say what you exactly see?
Yeah, 3 and 3. We did do it.
Another problem was exactly the same, and we didn't work it out.
It's 1 to 1. So at the end of the day, it's the same math problem. Yeah. Yeah, now I can do it. Where's the packet money? Alright. Alright, so the next problem. Yeah. Oh, sorry. What's up? That's the amount of product you're going to form using the limiting reactant. That's how much excess reactant is left over. That was not part of this problem. So in this case, all it's asking is, what is the limiting reactant? It's AgNO3. How much of the product is going to be formed? You're going to choose the product prediction that you got from using your limiting reactant. So that's how much you're actually producing. Alright, so a couple of reminders when you're doing limiting reactant. Reagents and reactants are used interchangeably. It's on the other side. It's on the other side. Here, okay. Oh, gotcha. Limiting reagents are always a reactant. A limiting reagent can only be determined by doing the calculations. It is not necessarily the reactant you have the less of at the beginning. Just because you have a problem that says you have 10 grams of this, 20 grams of the other guy, don't choose just the 10. You have to do the math before you go ahead and do it. Sure. Okay, next problem is essentially the same problem. I gave you the balanced reaction. I would like for you to try this for the next 10 minutes. Alright, so we're starting out pretty similarly. We're making two predictions. First prediction includes 18.3 grams of C3H6. Since it's asking for what mass of C3H3N is going to be made, my prediction is going to go from this guy to this guy and this to this. Alright, so by doing this next step, all I'm doing is converting it to moles. My grams of C3H6 is going to cancel and give me the number in moles of C3H6. Using the mole ratio, I can figure out how many moles of C3H3N are coming out. Because it's 4 to 4, it's going to get the same thing. Now, my moles of this unit cancels, and I'm left with the moles unit of the one that I want. But it's asking for the mass, so I'm going to go ahead and convert this to mass. And my final answer should be 23.1 grams of C3H3N. That is if C3H6 is my limiting reactant. What that translates to is that I have enough C3H6 to make up to 23.1 grams. Let me run through the problems first and then I'll answer questions. Second prediction, I'm going to use NO as my reactant. So when you work this out, you're starting out with 19.1 grams of NO.
What are we going to?
You're going from grams to moles to convert the NO into moles. Your grams of NO cancels out, whoops, and you're left with moles of NO. I'm still looking for the same amount of product. Remember, you have to write the reaction to go to the same product. Mole ratio is going to be 6 to 4. Moles of NO, cancels. It's again asking for the mass. So when I solve for the mass, I get 22.5 grams of C3H3N. So now, that translates to, I have enough NO to make up to 22.5 grams of C3H3N. Between the two, my least amount of product that I predicted is 22.5 grams, which then means that NO Oh, sorry.
You good? You good?
NO is my limiting reactant. And 22.5 is what?
22.5 is your theoretical yield. Hey!
This is your theoretical yield. Now, I'm going to switch it up real quick. If I already decided that, hey, put that down. If I'm asking you, all right, now I know that that's my limiting reactant, and I know that this is my theoretical yield. What if I want to know how much of how much of C3H6 is going to be left over? This is how you calculate it. Okay. You know that you still have to keep everything in the number of moles, correct? So, if I want to know how much the excess reactant is going to be left over, you now have to go from this, since this is your limiting reactant, to this. This is what it's going to look like. This is not part of your notes, but I suggest you write this down. You're starting out with the same amount of grams of NO, because that's my limiting reactant. You have 19.1 grams of NO. Convert that to moles using this mass, 30 grams of NO for every 1 mole, and NO. But instead of the usual way of going from NO to the product, this time I'm going to go where? To which substance? Because now I'm trying to figure out, if I have this much of NO, how much of C3H6 will I need to put in there? So I'm going to say for every 6 moles of NO, I'm going to need 4 moles of C3H6. But I'm going to have to do this in grams. So I'm going to have to put in 1 mole of C3H6. I got 42.09 grams of C3H6. Could someone put this on a calculator and calculate it? .83 grams of C3H6. So what that means is that after I decided that NO is my limiting reactant, and that whatever NO is going to produce for C3H3N is my theoretical yield, I'm asking, if I'm going to use up all of my NO, how much of C3H6 will be left over?
17.
So, if I'm going to do from NO to C3H6, I'm starting out with the same mass of NO, converted to moles of NO. Then you're going to say for this many moles of NO, I'm going to need for every 6 moles of NO, 4 moles of C3H6. Then, by converting whatever number of moles of C3H6 I found, I'm going to convert that to grams. So that means I need 17.83 grams of C3H6. So, I need 17.83 grams of C3H6. But I have initially 18.3 grams. So how much is left over, Elizabeth? 1.27 grams is left over, because if I have 18.3 grams to begin with, I only used up 17.83 grams, I'm going to have 1.27 grams left over.